It's asking us to graph each inequality, and then we're going to be doing the same thing of testing points, except given a graph, this is actually a little bit easier, so we'll be able to move through these pretty quickly. Okay. So I'm going to start right here. So because we are graphing, it's now going to be pretty important that our equation is in slope-intercept form. Because we need our slope and we need our intercept to be able to graph. So this first one is already in the form y equals mx plus b. So that's a good thing. So if I notice that, if it's not in slope-intercept, that's the first thing I'm going to do. If it is in slope-intercept, I'm going to go ahead and write down what m equals and what b equals. So looking here, it's y equals mx, so m is positive, 1/3, and b is -1. And then I can go ahead and kind of sketch out my line. So b is -1, m is 1/3, so that means I'm going to go up 1 over 3. So up 1 over 3, up 1 over 3. Can also go down and over to continue this line. Okay, so that is kind of the dot of my line. But since we're dealing with inequalities, we also need to figure out if this is going to be a solid line or if it's going to be dotted. So I look at my inequality symbol, which is less than or equal to. Because it has the or equal to part, the line, it means that it's going to be solid. So I'm going to connect these dots with a solid line. Okay, so I have my line. It's solid, and so now the final part is to decide where the shading is going to go. So what I do is I kind of think through this, and I ask myself, okay, if y has to be less than the line, where is y less than? Well, if we're going up, y is getting bigger or greater. It's becoming more positive. As we go down, y is becoming very negative, so it's actually becoming less. So the shading, if y needs to be less than, is going to go down, like this. So we have a solid line with the shading going down. So now we can answer these questions down here about whether or not these points are a solution. I see a question, how many questions is the quiz? I believe there are 7 questions, but some of them have like tables like this where you're answering multiple questions about whether it's a solution or not. So here we're going to test points. So I'm first going to test the point 0, 0. I'm going to actually plot this point so that I can make sure I know what I'm looking at. 0, 0 is the origin right here. It is not on the line. It is not in the shaded area, so no, it's not a solution. The point -2, 6, I go over 2, up 6. I can already tell that's way up here. That is not a solution. -5, -4, I go 1, 2, 3, 4, 5, and then down 1, 2, 3, 4. That is in the shaded area, so yes, it's a solution. And then 1, 3, it's right here. It's not in the shaded area, so no. If there was a point on the line, like the point 3, 0, because it's a solid line, points on the line are a solution. But that is not the case with a dotted line, so just keep that in mind. So moving on to the next one, I'm going to take a look at this equation. Y is greater than or equal to 7/5 x minus 2. This is already in slope-intercept form, so I can go ahead and pick out my slope and my intercept. Okay, so I'm going to write m equals b equals y equals m is 7 over 5. B is -2. So that means I'm going to start -2, and 7/5 means I'm going to go up 7 over 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Now I can't continue that pattern because that is quite a big slope. So I'm just going to connect the dots between these two lines. In order to do that, I need to know if my line should be solid or dotted. So I'm going to look at the inequality symbol. It's a greater than or equal to. Because it has the equal to part, the line, it's going to be solid. So I draw that line there. And finally, I need to decide where my shading is going to go. If I look back up here, it says y is greater than or equal to. So where is y greater than? Up here, y is greater than. So I'm going to shade above the line. So anything above the line, and because the line is solid, including the line as well. So down here, it's not asking me to test points, but it's actually asking me to write in my own points. And so you might have gotten different answers for this, but the way that you do this is if, like right here, it wants me to give a point that is a solution. So I'm going to look anywhere in the shaded region, or I could actually pick a point on the line because it's a solid line. So I could go ahead and pick this point right here, the y-intercept, which is 0, -2, is a solution. Next, it wants me to give a point that's not a solution. So how about this one right here? It's not in the shaded, so that would be 2, -2 is not a solution. Another one that's not a solution would be here, 3, 0. And then another point that is a solution, I could pick right here, which is -2, 2. So you could have picked any numbers that are either in the shading if they are a solution, or not in the shading if they're not a solution. All right, so moving on. These are going to get a little trickier only because we should notice this right away. It is not in slope-intercept form, so I need to go ahead and do that first. So to get this in slope-intercept form, I want to solve for y. And so I need to move this x out of the way. So I'm going to subtract it. Because it's a positive x, I'm going to do -x on both sides. That leaves me with a -3y is less than -x minus 3. Now, to get rid of the -3, I'm going to divide everything by -3. To be really careful, because this is an inequality, when I divide or multiply an inequality by a negative, I have to flip the sign. So I'm going to flip this in my next step. So I get y, these cancel, y is greater than, and then once again, we want to be careful here. I have, this is like a -1. So I have -1 over -3. Those negatives are going to cancel, leaving me with 1/3. So I have 1/3 x, and then I have -3 divided by -3 gives me a +1. Okay, so now that I have this in slope-intercept form, I can write down m equals and b equals. Looking at the equation, m is 1/3 and b is 1. M is 1/3, b is 1. So I can go ahead and sketch my graph here. So b is 1, puts me here for my starting point. A slope of 1/3, it's positive, means I'm going up 1/3. So up 1/3, up 1/3, down and over, down and over. I want to know if I should make my line dotted or solid, so I'm going to check the symbol. Y is greater than, there's no equal to, so this line is actually going to be dashed. So I'm going to connect these dots with a dashed line. What the dashed line means is if there's a point that's on the line, that specific point actually isn't part of the solution, but anything in the shading is part of the solution. So we'll see that in just a minute. Now I need to decide where my shading is going to go. So it's y is greater than. Where is y greater than? Y gets bigger as it goes up, so I'm going to shade above the graph. Up here. Okay, and now we can check these points. So it's asking, is the point -2, 6 a solution? So I'm going to plot it. -2, 1, 6 is up here. Yes, that is a solution. Next is the point -1, 5. -1, 5 is right here. Yes, that's a solution. The next point is 3, 3. 3, 3. Yes, that's a solution. And then 4, 1. 4, 1 is right here. So no, it's not. Also important to note that if I asked you if 0, 1 is a solution, the answer would be no, because it's a point on the line, but the line is dashed, so that means it's the same idea as an open circle when we were doing our number lines, that anything in the shaded region is a solution, but anything exactly on the line is not a solution. So keep that in mind. Okay, last one here. We want to check, see if it's in slope-intercept. It is not, so I need to do that first. So I need to get the y by itself. So I'm going to move this x over by subtracting it. And so I get y is less than or equal to negative x plus 2. Now it's in slope-intercept, so I'm going to write my slope and my intercept. My slope is negative 1. My intercept is 2. So I'm going to put my starting point at 2 right here. A slope of negative 1 is like negative 1 over 1, so I'm going to go down 1 because it's negative over 1. So down and over, it's going to follow this pattern, and then up this way. So I need to decide if I'm going to do a dotted or a solid line. So I need to look at my symbol. My symbol is less than or equal to. So because it has the equal to, it's going to be solid. The last step is to decide what kind of shading I'm going to have. Since y is less than or equal to the line, y is less than as we go down, so I'm going to shade underneath. Okay, and then in this one, it's asking me to once again pick my own points. So it wants 3 points that are not a solution and then 1 point that is a solution. So not a solution, I could do 0, 4. I could do 4, 1. I could do 3, 3. For a point that is a solution, I could pick up any point on the line or in the yellow, so in the shaded. So I'll do the origin. 0, 0 is a solution to this one. Okay, so that is how you graph linear inequalities and check for solutions on a graph. There's one more page. So I'm going to scoot over here. For these ones, the directions are kind of hidden. I think they got put over here. We're going to write an inequality to represent the graph. So we're doing the exact opposite of what we just did. This time I'm going to look at the graph and I'm going to come up with an inequality that will work. Okay. So, number 10. We need to take in consideration 3 things. The equation of the line, so I need n and b. I need to take into consideration whether it's dotted or solid, and then where the shading is at. So I think we discovered the other day that it's probably easier to start with y and then decide if the symbol, where the symbol should go by looking at the shading. So in this one, the shading is going up towards positive y. This is big y. As this line goes up, y is getting bigger and bigger. It's increasing. As we move down, y is decreasing. So the shading is on the increasing y. It's getting larger, so it's going to be greater than. But then I need to check my line to see if it's greater than or equal to. This is a dotted line, so it's just going to be greater than, no line underneath. So I have y is greater than, and then I need to just figure out what m and b are so I can plug those in. So I want you to actually write this off to the side. I'll start with b. It's where it crosses the y-axis. It crosses at -3. And then I need to pick a second point to find my slope. It looks like it crosses through here, so you could pick any of these points. And then we're moving from left to right. First thing I want to notice, this is going down, so my slope is going to be negative. And then I'm going down 1 over 2, so it's -1/2. Now that I have m and b, I just plug them in. Y is greater than m, -1 over 2, x, plus b, but this is -3, so I'm going to say -3. All right, number 11, same thing. I'm going to start with y. I need to decide if y is greater than or less than. This line is very steep, but still I can see that the y that's going up, that's getting bigger, is included in the shaded area. Y that's going down over here, it's not shaded. So y is actually going to be greater than again. And is it going to be greater than or equal to? I look at the line. This is a solid line, so it's going to be greater than or equal to. Now I just need to find m and b, so I can plug those in to mx plus b. starting with B, it looks like we're crossing at +3. I need another point to identify my slope. It doesn't look like we cross again until down here. And so this slope is going up very steep. So it's going to be positive, and I'm going up 1, 2, 3, 4, 5, 6, 7, 8, and over 1. So it looks like up 8. I'm going to count that again. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Up 8 over 1. So that's a slope of 8. Very steep line. So just plug these in. Y is greater than or equal to mx plus b. And that's it. Next one, I'm starting with y. Decide if it's greater than or less than. Well, this time the shading is going down. Positive y that's increasing is here. It's not shaded. Y that's going down and decreasing is shaded. So this is going to be a less than. I notice that my line is solid, so it's less than or equal to. Now I need to find m and b. B is right here at the point at 0, 1. And so I need another point to identify my slope. It doesn't look like it's quite crossing through until here. So I notice first that this is going down, so my slope's going to be negative. And I'm going down 1, 2, 3 over 1, 2, 3, 4. So this is a slope of -3 over 4. Plug these in. Y is less than or equal to m, -3 over 4, x plus b, which is +1. All right, last one of these, starting with y. The shaded region is on the y that's going up, so it's going to be greater than. The line is dotted, so it's just going to be greater than, not equal to. I need to find m and b. B looks like it's crossing at -3. I need another point to identify my slope. I see one here, and I see one, oh, that's not right. Back up. I don't know if that's right. Here and here. Okay, so it's here and here and here. Okay, and here. That's right. Okay, so my slope, I want to notice it's going down, so it's going to be negative. And I'm going down 1, 2, and over 1. So that's -2 over 1 or -2. So I plug these in. M is -2. X plus b, this is a -3, so I'm going to write -3. Okay, that is how you write an equation for a linear inequality. And so we're moving on to these last ones, which are application problems. So 14. First thing I do when I'm tackling application problems, I just read first and try and figure out what the situation is. So it says, a moving van has an interior means inside, height of 7 feet, and it's giving you the measurement in inches as well, 84 inches. You have boxes in 12-inch and 15-inch heights and want to stack them as high as possible to fit. Write an inequality that represents this situation. So think about what's going on. Someone's moving, and they only have 7 feet of height on the inside of their van. So if you picture like a van, this is not a very good drawing. Here's the wheels. Here's the trunk. The trunk is opened up, and you want to try and fit as much as you can in here. So here, put the front. This does not look like a very good van. Okay, so you're trying to fit as much as you can. And there's 2 types of boxes. Oh, and it's saying this total is 7 feet or 84 inches. Now, we need to think about which unit's going to be best here. So it says you have boxes in 12-inch and 15-inch heights. If these are in inches, then I want to use this height of 84 inches. So the total height is 84 inches. And I want to stack as many boxes as I can. Some of them are 12 inches and some are 15 inches. So some are big, some are small. And I want to stack them as high as possible, so I'm going to write an inequality that represents the situation. So what I have is I want to take up as much space as I possibly can. So how we do this is we say, I'm going to call the small boxes S, and I'm going to call the big boxes B. And I want to get to a height of 84, because that's the total height. So I want 12 inches. I'm going to take up 12 inches for every small box I use. So I'm going to multiply 12 times S. And then I'm going to add 15 inches for every big box I use, which is B. And what I want, this is 12 inches times however many small boxes I have, plus 15 inches times however many big boxes I have. I want this to be less than or equal to my total height, which is 84. If this is any bigger than 84, then it's not going to fit. So I want it to be less than or equal to. And so I can use this inequality to be able to solve for how many, if I had one small box, how many big boxes could I fit? If I have, 3 big boxes, is that going to work for one? And if so, how many small boxes can I fit? So this is the inequality you'd use. 12S plus 15B is less than or equal to 84. Now, you could use like X and Y, but you'd probably want to define those terms and say X equals small box, and you would want to say Y equals big box. But because I used S and B, and I labeled them up here too, you can understand where those variables are coming from. So this next one is another word problem, and we're going to think through it the same way. So Sachi found a used bookstore that sells pre-owned DVDs and books. DVDs cost $9 each, and books cost $7 each. Sachi can spend no more than $35. So this one's pretty straightforward. She has $35 to spend, and there's DVDs, which are $9, and then there's books, which are $7. So we're going to write an inequality that represents the situation of how many things Sachi can buy without going over, or without completely, without spending more money than she has. So DVDs are $9 each. That means 9. I'm going to multiply $9 times however many DVDs. So I could use D. 9D plus, because she's also buying maybe some books. The books are $7, so I'm going to multiply 7 times however many books she buys, B. And this amount, $9 times however many DVDs, plus $7 times however many books, that needs to be no more than 35, meaning it has to be less than or equal to $35. Because if it's more than, she doesn't have enough money, and that's a problem. So here's the inequality. 9D plus 7B is less than or equal to 35. And I could even label this up here. This is D, and this is B. So there's a follow-up question. Does Sachi have enough money to buy 2 DVDs and 3 books? So it's giving me amounts here. So what I need to do is plug this in and see if it works. So I'm going to do 9. Instead of D, I'm going to put 2. 9 times 2 plus 7 times, she's getting 3 books. And I want to see if that's less than or equal to 35. 9 times 2 is 18. I have to do it over here. 18 plus 7 times 3 is 21. 18 plus 21 would give me 39. 39. So is 39 less than or equal to 35? No. So no, Sachi does not have enough money to get 2 DVDs and 3 books. She would have to get, drop one off. She can't get it all. All right, so that is the entire study guide.